Quantum Computing Breakthrough Prize. Well, stop the presses, as we say. Or we interrupt normal programming to bring you some news. And we don't do news here at ToKCast. We do the timeless, not timely. But here is one of those rare exceptions. And I'll try and make the timely as timeless as I possibly can. David Deutsch has shared in the winning of the Breakthrough Prize. What is the Breakthrough Prize? Okay, so it's not the Nobel Prize, but if scientists and others are asked to rank, let's say, the top prizes in science on one hand, then after the Nobel Prize comes the Breakthrough Prize. Somewhere up there anyway, if you're counting on one hand. It's very top tier. I mean, just Google most prestigious awards in science. David will no doubt cringe, and so might others in my circles or even fans of ToKCast. But truth be told, on ToKCast, I really do focus almost exclusively on the ideas. David Deutsch, of course, regularly gets acknowledged as the originator of many of these ideas, and the original expositor of them, of course, but I don't tend to focus on the singular intellectual mind that is David Deutsch. But today, with the recent award of that prize, I will take, as they say in the Australian Parliament, a moment on indulgence when matters arise that are outside the usual stream of business. I think this occasion warrants it. And many of the articles written today, and there are many, and if you go to my website linked to this particular episode, I will put a list of those articles there, and they go into this kind of glowing acknowledgement of David's contribution to science and physics in particular broadly. At the website of the Breakthrough Prize, they say, right up front, quote, "Knowledge is humanity's greatest asset. It defines our nature, and it will shape our future. The body of knowledge is assembled over centuries, yet a single mind can extend it immensely. Einstein reimagined space and time. Darwin distilled the chaos of life to a single idea. Turing figured out what it means to think. Great scientists enrich us all. They enable technologies that ease our lives, but they also show us what's beyond our horizons," end quote. I don't think I've ever read such a wonderful beginning of infinity style paragraph outside of the beginning of infinity in a long time. The idea that knowledge is humanity's greatest asset. It defines our nature. It will shape our future. It can show us what's beyond our horizons. This is fantastic, wonderful, deep stuff. And correct. This is great. It's a glorious introduction to the process of science right there and knowledge creation. It at once dispels the myth of the lone scientist working alone in isolation and being the giant for others to stand on the shoulders of. There is a pervasive idea right now denigrating the whole notion of the heroic lone mind literally creating explanatory knowledge. Today, the dogma being forced upon us is that it is always almost entirely a collaboration or a cooperation. This may be true of the industrial style, modern academic-centric style of incremental science that is done, the publish or perish doctrine of careerism in the sciences. It is a shame, and it's certainly, and I would never blame, not the fault of those scientists working in those areas in the main. They are victims of a particular kind of system. But some heroes manage to buck the trend through what must be said choice and force of individual will alone. The iconoclastic individual coming up with insights precisely because they insist they work best alone. I would say uncontaminated perhaps by groupthink or the need to fall in line politically, ideologically, spiritual, philosophically and scientifically. Isaac Newton was one, Albert Einstein was one, Alan Turing was one, David Deutsch is one such as well. And in being so, was able to bring the discussions around computation, its potential and its limits, then regarded as a part of pure mathematics, into physics. And in doing so, invented the theory of quantum computation. So he was standing up against an establishment that thought that this thing was just pure mathematics. This is the reason David won the Breakthrough Prize, for his contributions to the foundations of that field. But what's the big deal about quantum computation? Okay, well, let's go to his book, The Beginning of Infinity. A few choice quotes come to mind. Beginning with, quote, "Quantum computation, which is currently believed to be the fully universal form of computation, happens to have exactly the same set of computable functions as Turing's classical computation, but quantum computation drives a coach and horses through the classical notion of a simple or elementary operation. It makes some intuitively very complex things simple, end quote. And later on, he goes on to explain how quantum computers actually work. And he says, quote, in one type of quantum computation, enormous numbers of different computations taking place simultaneously can affect each other and hence contribute to the output of a computation. This is known as quantum parallelism. In a typical quantum computation, individual bits of information are represented in physical objects known as qubits, quantum bits, of which there is a large variety of physical implementations, but always with two essential features. First, each qubit has a variable that can take one of two discrete values. And second, special measurements are taken to protect the qubits from entanglement, such as cooling them to temperatures close to absolute zero. A typical algorithm using quantum parallelism begins by causing the information carrying variables in some of the qubits to acquire both their values simultaneously. Consequently, regarding those qubits as a register representing, say, a number, the number of separate instances of the register as a whole is exponentially large, 2 to the power of the number of qubits. Then, for a period, classical computations are performed, during which waves of differentiation spread to some of the other qubits, but no further, because of the special measures that prevent this. Hence, information is processed separately in each of that vast number of autonomous histories. Finally, an interference process involving all the affected qubits combines the information in those histories into a single history, end quote. And thus, I would say, the output, therefore, of the quantum computer. And later he goes on to say, quote, in such computations, a quantum computer with only a few hundred qubits could perform far more computations in parallel than there are atoms in the visible universe. At the time of writing, quantum computers with about 10 qubits have been constructed. Scaling the technology to larger numbers is a tremendous challenge for quantum technology, but it is gradually being met, end quote. For more on this, of course, pick up The Beginning of Infinity. Just do a word search if you've got the Kindle version, looking up quantum computation, and go back over what David has to say about the field he began, because he provides very clear explanations of this. My own modest attempt to explain quantum computation can be found throughout my multiverse series, in particular part 3 of that series where I discuss The Beginning of Infinity, chapter 11, the multiverse. I think it's also episode 26 of ToKCast, so you can go back and listen to that. As I have said in episodes of ToKCast before, this work on quantum computation is why David Deutsch is most famous among his peers and other physicists, and possibly the second reason I found the ideas of David Deutsch to be worth promoting. The first was the existence of his first book, The Fabric of Reality. These days, whenever the question of what do you do comes up, or whenever I'm speaking to some group of younger people about something like the history of ideas and the present state of our knowledge, my in is typically computers. I can often ask people what they know about the origins of this thing, the computer, the smartphone they have. It allows me to explain the last name on that list that the Introduction to the Breakthrough Prize has on their website, where they name check those luminaries, Einstein, Darwin, and Turing. There is indeed debate about whether it was Charles Babbage, Ada Lovelace, Alonzo Church, or Alan Turing who was most central to the ultimate invention of the theory, as well as the implementation of computers, or rather computation as a field of mathematics, computer science and engineering, software and hardware development, and ultimately physics. But many, if their hand is forced, nominate Turing as the real key to all this. His approach was mathematical, but assumed a physical device. He laid the most important groundwork for modern, classical, electronic, universal digital computers that today we know as laptops, desktops, smartphones, and watches, tablets, and Teslas. Well, the onboard computer for the Tesla car anyway. Turing was an accomplished and unique thinker, and he gifted us the ideas that led to an understanding of the universal classical computer, often simply called the universal Turing machine. And he is the Turing of the Church-Turing conjecture, the hypothesis that any physical process can be computed, and the conjecture which Deutsch turned into the Church-Turing-Deutsch principle by proving it followed from assumptions of quantum theory, what we already knew about quantum theory. And if we go to the breakthrough Prize's list of names again. They've got those 3 names there. Einstein is there, the preeminent example of someone who redefined physics, largely from the ground up. Gravity was no longer a force once Einstein was done with explaining it. It was the curvature of space-time. Time was no longer a constant for everyone in the universe, just ticking away sort of outside of the universe. How fast one moved through time depended upon how fast one was moving through space. Lengths are not always the same for everyone. Masses, or momentum more precisely, are not always constant for a given body. They too are relative to a velocity. But the speed of light is always and everywhere constant for all observers. Light was no longer a wave, but something more complex and more like a particle. He had something to do with that. Entanglement is a thing. So Einstein rightly deserves the reverence he has in the pantheon of names. And likewise Darwin, of course, undid the magic of creationism and explained how life can adapt and thus change over time through a process of natural selection. Imagine if we could speak to Turing now, someone who ushered in an entire multi-billion-dollar industry of technology, radically transforming civilization. Imagine if Einstein was still alive and we could further question him about disrupting the foundations of physics. Imagine if we could interrogate Darwin on a podcast with what we know now about evolution. And let's throw in Karl Popper, of course, who, like Darwin, utterly overturned the entire field he was working in by explaining knowledge was no longer about parochial beliefs people had justified in their minds that we read from the Book of Nature or something like that, but rather was something truly objective and which could be out there in physical reality, transforming the world and the world of objects. So I say this sort of thing to people when they ask me about what I do and they wonder where I'm going with all this. And then I say, this is why I'm fascinated by the work of David Deutsch, because he has aspects of all of those people. It's why I'm fascinated in communicating with David Deutsch and trying to provide his ideas with more reach. Let's just go through it. Like Turing, Deutsch has actually transformed a billion-dollar industry. He laid the foundations of the field of quantum computation, and this is why he won the Breakthrough Prize. Okay, but like Einstein, Deutsch is beginning to transform the very foundations of physics, helping, along with others, to create an entirely new mode of explanation, constructor theory. And if anyone today is the intellectual successor to Karl Popper in philosophy, it is David Deutsch, who has updated a number of Popper's insights, refining and taking them further with, notably, his notion of good explanations and his exaltation of people as universal knowledge creators. And that is almost a spiritual idea. Okay, it's scientific, but what more do you want connecting people to the cosmos? It's amazing. Religious people can only dream that their ideas have something like that. And in explaining people as knowledge creators, he has explained the unification of Darwin's work in evolution with Popper's as both being examples of knowledge, being information that once instantiated somewhere tends to cause itself to remain so, something both genes and good ideas have in common. So it is wonderful and well-deserved to see David Deutsch winning the Breakthrough Prize. For me, it brings some additional and well-deserved prominence to his ideas, specifically about quantum computation, but hopefully to all of his other ideas as well, which can be world-changing. The optimism of David's perspective on Popperian epistemology as an unending stream of explanation creation that underpins potentially infinite progress needs to be far more widely known. It is the counter to a pervasive pessimism. His nascent constructor theory, developed with Chiara Marletta and other collaborators, needs to be explored more deeply. It could revolutionise physics and allow for more progress faster. He's done it before. He's done it with quantum computation. His books, The Beginning of Infinity and The Fabric of Reality, should still be at the top of bestseller lists, for their ideas are making an impact, but not enough of an impact, or fast enough. David Deutsch is not a guru. He's not omniscient, but he is modest, and he knows his own fallibility, because that is a trait shared by all humans. So he will say of constructor theory, it may fail. But of course, we all know that it may not. So it's worth trying, as he himself has wryly quipped before. String theory was worth trying. And indeed, it has been given a few decades now, hasn't it? We should at least have a generation of physicists, mathematicians, biologists, philosophers, and other scientists and intellectuals to investigate where constructor theory might go. David Deutsch is such a modest fallibilist that he does not actively try to persuade anyone that he's got the right ideas. He is not dogmatic. He will not force himself into conferences or public speaking engagements. It is for those reasons, among others, his ideas do need something of a promotions department, which is what I am beginning to do here. After all, David is too busy coming up with the actual ideas which will transform the world, so someone has to take on the task of outreach, and I am excited to do it. And David Deutsch is generous. But I will not say generous to a fault, because generosity is not a fault, and I don't think you can have too much of it. So his ideas are all out there in the public domain for free. All those papers on quantum computation. Or next to free. I mean, his books are worth far more than what they cost. And they have already had a disproportionate impact given what a single person can accomplish in a given lifetime. It is the age of speaking about equality and so forth. Well, if the world was equal or fair, Deutsch should be a billionaire, no? It is so early on in explaining all those ideas. Will they go on to have the impact the physics of Einstein in the 20th century did? Or classical computation of Turing did in the 20th century? Or the impact that 20th century philosophy did? Well, in the 21st century, David Deutsch now has all of that covered potentially with constructor theory, quantum computation, and his improvements on Popper. And I haven't even mentioned his substantive reimagining of Everettian quantum theory, which, taken seriously, can have foundational changes in our understanding of physical reality at the very deepest levels, including that of personal identity, I've argued. This notion of fungibility and what it means to be a person in the multiverse. Most of us missed living at a time when we could have heard Einstein speaking, much less spoken to him ourselves. All of us missed the opportunity to hear Darwin. We can only wish to have spoken to or have heard more from Turing. And while we can still hear Popper in his own words in recordings today, we can't hear any more from him. But we do have David Deutsch. This is something I have said to people for many years, and I have the sense they have sometimes gone away with a shrug of not really taking my implications seriously. Perhaps this award will help to do some of that work for me from now on. It only acknowledges the advances in quantum computation that he made, and though that is a big part of David's work, it's far from all of it. The whole of it is extremely diverse, almost as diverse as it can possibly be, for it covers the very fabric of reality. It itself is a beginning of infinity. If you're fascinated with one part of it, explore the rest. There really is no end to it once you begin. And if you've taken seriously the implications of what I've said here now, then why aren't you following David on Twitter? At David Deutsch, just like his name, at David Deutsch OXF, short for Oxford. And why aren't you keeping up with what's happening at the website, www.constructortheory.org? And why don't you have copies of his books bought for family and friends? One day, you might be able to say with a knowing smile and a little bit of intellectual pride, when the guy at the local phone store is trying to upsell you to the Apple Quantum Q Phone Pro Max and begins to explain how it works using the multiverse as explained by that guy on the new £50 British banknote. Yeah, you say, I know of David Deutsch. I knew of him way before we all had quantum computers and universal constructors everywhere. I've even read his book. Don't you mean books, says the salesperson. So, congratulations to David Deutsch for winning the Breakthrough Prize. At the website for this episode, linked to in the description, is a list of the articles so far written about David's latest award. Many of them do a very fine job of explaining for a layperson the fundamentals of quantum computation and why it's important. Until next time, when we return to regular programming, bye-bye.